Hello, this is Dr. Mears, and today we're going to be learning about the reciprocal function. The reciprocal of a number is 1 divided by that number. So if we have the number 2, to find the reciprocal, because that's what we have to do in our example, is to find the reciprocal of each number and expression, what we do is we're really going to put this over 1. So the numerator is 2 and the denominator is 1. To do the reciprocal, we do just flip it. So instead of 2 over 1, it's 1 over 2. To find the reciprocal of -1/2, we keep the negative, that stays. We're not worrying about the negative, but we are going to make the numerator the denominator and the denominator the numerator. So we flip it. Okay, here we have an expression x. Well, let's put that over 1, and you're just going to flip it, 1 over x. Now this expression is already in fraction form, so t over d. And that's it. Next examples show that the product of each number and its reciprocal is equal to 1. So product is multiplication of each number. So we're going to take the number 5 here and multiply it by its reciprocal, 1 over 5. So let's make this into a fraction, 5 over 1. Well, 5 times 1 is 5. 1 times 5 is 5. 5 divided by 5 is 1. That's it. All I did was I just multiplied across and then I reduced. So 2 over x, the product times its reciprocal, x over 2, equals, let's multiply across, 2 times x is 2x, x times 2 is 2x, 2x divided by 2x is 1. These both check out, and that's it. Let's go to our next examples. The reciprocal function f of x equals k over x, where k is a non-zero constant. So basically they're saying that this is a number, not zero. That's what this means, non-zero constant. This is what the graph looks like. Here's our x-axis, here's our y-axis. This is part of the curve, and this is the other part of the curve. If you notice the domain, now if we look at the x values, if we read this from left to right, this curve is going towards all the negative x values, so it keeps going here. This curve is going towards all the positive x values. So it's all real numbers. However, let's notice it's not going past the x-axis. It'll never touch it. That's actually going to be part of our asymptote. Remember, an asymptote is where our curve is going to get very close to some line but never cross it, and our line is actually that x-axis. Looking at the range, looking at this graph from going all the way down, it's going to go all the negative y values, and looking at this graph going all the way up, it's going to go all the positives. So this is all reals as well. However, notice it's not going to cross the y-axis, so it can't be 0. So you can write it like this. If you want to write it as XER, you can write it like that, where an x does not equal 0, absolutely fine. And YER, where y does not equal 0, that's fine as well. All right, let's look at the asymptotes. So the horizontal asymptote, that's the one that goes horizontally, is going to be the x-axis. It's the x-axis. Now, instead of writing the words x-axis, we can write it as the equation y equals 0. So either we can label this as x-axis, or it's actually the equation y equals 0. I know they're opposite. You know, that's what happens in mathematics. So we'll never cross the y equals 0 line. This is the y equals 0 line known as the x-axis. Vertical is going up and down. We know it's not going to cross the y-axis. How can we write that as an equation? Well, we can write x equals 0, and that's this axis right here, the y-axis. All right, what do we have to do? Let's do our example. Sketch the graph of each function. Use your graphical display calculator and state the domain, range, and asymptotes. So what we're going to do is take out our graphing calculator, press on, go to our y equals and clear anything that's out. We're going just to put 7, and then this is divided by, so press the division symbol and then x. And what I'm going to do is I'm going to press zoom and then I'm going to press standard. What that gives you is a 10 by 10 grid, and that'll be good for most of these. We're not using very high or low numbers. So if you notice, it looks exactly like this graph, doesn't it? Exactly like this graph. So what we can do is we're just going to sketch it. So let's just sketch it here. Here's x, here's y. Sketching our graph, that's great. What are we going to notice about our domain and range? Same exact thing. Same exact thing. So our domain is going to be all reals, not zero. And range is going to be all reals, not zero. How about our asymptotes? Well, our horizontal asymptote, is going to be same thing, x-axis, or you can write it as y equals 0. I really like writing it as y equals 0 here. Our vertical asymptotes is going to be our y-axis. It's the same exact thing, or x equals 0. So there we go. Number 2. Let's go back to our graphing calculator. Let's clear that out. Let's do negative now. Negative 7 divided by x. Let's push graph. Oh, look at that. Very interesting. So it's on the other side. Almost looks like it got flipped. So let's draw that in. So now it's in the second quadrant and the fourth quadrant. Okay, so let's do our domain. Our domain is looking at the x-axis, and we can see that this is going to go towards all the negative values, and this one's going to go towards all the positives. So it is going to be all reals, but what is not going to cross? Not 0. All right, let's look at our y values. This is going to go all the way up to all of our y values, positive y values. This is going to go all the way down to our negative y values. So again, all reals, not 0. Okay, how about our asymptotes? Well, same thing. Our horizontal asymptote, it's not going to pass the x-axis. So y equals 0. It's not going to pass that one. And our vertical asymptote, same thing. It's going to be our y-axis, which is x equals 0. You can write it either way you want. Either way you feel comfortable, you can write it. So it's just not going to pass that x and y. Now, hopefully you're thinking, are the asymptotes going to change? Yes. This is your basic reciprocal function where you have a constant, non-zero constant divided by x. We are going to start adding numbers into the denominator and numerator, and you're going to see this shift. You're going to see this transform. So it's not always going to be at y equals 0 and x equals 0, and we're going to look at that a little bit later on, actually in part 2. So let's apply our knowledge. So reciprocal functions in the real world. We have Adam's mobile phone has a limited amount of free space, which he can use to store photos. Adam's phone has 240 megabytes of storage. The phone settings allow Adam to choose the default photo size in megabytes, which is the amount of storage space each photo occupies on the phone. So we run out of storage all the time, right? I have to delete these pictures because there's too many pictures. I don't have enough storage space. So let's complete the table, which shows the default photo size and the number of photos that Adam can store. So we have our X value, which is going to be our megabytes, and our Y values, which is going to be number of photos. So here we have 2 megabytes. So let's look at how many he has total. He has 240. So if we start off with 240 and we divide out 2 that we just used, how many do we have left? If you do that in your calculator, 240 divide out how many we use 2, I get 120 left. So in completing this table, what we're going to do is we're going to put down the total megabytes and divide out the megabytes that we used, which makes sense. We have to take out what we used. So 240 divided by 3 gives us 80. 240 divided by 4 gives us 60. This is going to be 48, and I'm just going to fill this in. You can go and divide the total. So it was total number of megabytes divided by the photo size. Oops. That's what I did for these here to get this table. That's 24, 20, and 8. Okay. Part B, write the function y, the number of photos Adam can store in his phone, in terms of the photo size x. Well, I have it right here. Y equals, well, what is our total? Our total is going to be total 240. And we divide out the megabytes, or x, which is our photo size. That's it. Use your graphical display calculator to plot the function you found in part B. I bet you that it's going to look very similar to the ones that we've done. So let's clear out what we have. 240 divided by x. Let's graph. Okay. Now, what do you notice? You notice that there's nothing on our graph, and that's because we used a 10 by 10 grid. We're at 240, everybody. We're not going to be able to see this on a 10 by 10 grid. So let's press zoom, which is this middle button right here. And I'm going to try to fit it. So if you push the up arrow button, you get to zoom fit. And that's going to help to fit the, zoom. I actually have to press enter, everybody, enter. And that's going to actually fit the graph to your calculator. So I just press zoom fit, which was 0. 0 was zoom fit. All right. So let's sketch this out. Very similar to what we had. Looks exactly like this. There we go. Here's X, here's Y, and that's it. Okay. Part D. Use the graphical approach. Oops, sorry, part D. Now they always put, what IB does this, they always put this extra information in, and sometimes you miss it. So if you're reading a problem and you're like, oh, I think we need more information, look to see that you didn't miss anything, because they love to put these little sentences in. So let's see this extra information that they threw in. Adam wants to have space to store 50 photos. So if we look back here, 50 photos. So number of photos, that would be about between here and here. So we know it's going to be between 4 and 5. So we have to figure out 50 photos on his phone. Use the graphical approach to find the maximum individual photo size. So when we do this, we're going to put in y1, our function, 240 divided by x. And in y2, we're going to put 50, because that's how much he wants to have stored on his phone. And we're going to see where they cross. So let's put y equals, I already have the 240, let's put 50, graph. Okay, so we have the blue curves and the red line. And where the blue curve and the red line cross is going to be our answer. The x value is actually going to be our answer. So here's 50 here. So we want this intersection, and we want the x value, because our y value is going to be 50. So that's what we want to find. So what are we going to use? Yes, exactly what we've been using all year. Second trace. We're going to go to 5 for intersect. Now it says first curve, and I'm just going to press the right button just to make sure that it's on this curve right here, which it should be. So I just pressed the right arrow button a little bit, and yes, I want it on that curve. It says second curve, and look, it's even turning red for us. So because it's on the red line, it calls it a curve. Press enter. Want me to take a guess? Press enter again. And we see that it's 4.8, 50. So this right here was 4.8. So this is our intersection point. So maximum individual photo size is 4.8 megabytes. Oh, there's a lunch bell. Didn't make it. One more left before that lunch bell. Oh well, let's keep going. Use an algebraic approach to find the maximum individual photo size. Okay, so 50 photos. So photos is our x. That is our x. Oops, sorry. Photos is our x variable. So what we have to do is y equals 240 over x. Remember, x was photos, and that's what we found over here, right here. Total divided by the photo size. Photo size is x. So they gave us that, photo size. So we have to substitute it in, 240 divided by 50. And when we divide that out, it's going to be 4.8, and that is definitely going to match up with what we got graphically. So you can either do it graphically on your graphing calculator, or you can find it algebraically by using substitution. So this has been reciprocal functions in the real world, understanding what a reciprocal is. Good luck. Hope it helped.